Now, let us move to activity 3. We have to verify the second law of reflection that includes the incident ray, the normal at the point of incidence, and the reflected ray lies in the same plane. What we require a plane mirror, a sheet of stiff paper, a light box, wooden block, and a pair of scissors. So these things are required. Now we have to take a plane mirror and place it on a sheet of stiff paper a little beyond the edge of the table so that reflecting surface is facing sideways. I will show you the diagram what you have to do. See, you have to take a plane mirror dash and you have to place it on the sheet of stiff paper beyond the edge of the table so that its reflecting surface is at the facing sideways. Mark the position of the mirror on the sheet of the paper. अब हमने इस mirror की position को mark करनी है. Keep the light box at position A. You have to keep this box. See, this is position A. You have to keep this light box so that it is facing this side. When you open the slit of the light box, a beam of light, this is a beam of light, see here, this is a beam of light which is incident on the plane mirror. You can see the beam of light AO strikes the mirror surface at point O. ये point O पर strike करेगी and it goes in the another direction. And the another direction I'll show you. This is the another direction where it is going. This is the reflected. Cut the projecting portion. Now what you have to do? You have to cut the projecting portion of the sheet in the middle along the normal. Now you have to this is the scissor. You have to cut the paper along the sheet in the middle with a pair of scissors. The reflected ray extends to the projected portion of the paper. Now bend the part of the projected portion on which the reflected ray falls. Now what you have to observe? See it carefully what we have observed. The time reflected ray will not fall on the folded part. When you bring the paper back to the original position, you can see the reflected ray again. Can you tell me why this happens? When the whole sheet of paper is spread on the table, it represents one plane. Okay, when this sheet of paper is complete here, this is one plane. The incident ray, the normal ray at the point of incidence, and the reflected ray all lies on the same plane. But when you bend the stiff paper, you create a plane different from the plane in which the incident ray and the normal ray lie, but we don't see any reflected ray. So what we have concluded? We have concluded that the incident ray, the normal ray, and the point of incidence and the reflected ray all lie in the same plane. This is the second law of reflection. So we can say that we have read two laws of reflection. The first law states that the incident ray angle I is equal to angle R. This is the first law. And the second law is incident ray, normal, and reflected ray lies on the same plane. So this is about this topic, And one more thing I'll discuss, when a ray of light falls normally or perpendicularly on a plane surface, means when the angle of incidence, if you can say, it is a 90 degree, okay, this is reflected back along the same path. See, I'll show you what I am saying, that when this is, suppose this is a plane mirror and this is the known reflecting part where I am shading. If the ray of light is going at straight, then it will come back in the same direction. Why? Because when a ray of light is incident normally on a plane mirror, it is traveling along a normal to the surface of the mirror. Therefore, the angle of incidence is 0. So, according to the first law, the angle of reflection would also be 0. Thus, the incident ray falling normally on a mirror is reflected back along the same path. You have to take care this point. In this case, the same line represents the incident ray and the reflected ray. Suppose this is the mirror, this ray is going normally, the same ray will come back, and this line also represents the reflected ray. So this is what we have done today. So we'll be starting with the next topic in the next class. Till then you have to read. Thank you.